dx is going to be equals to dy over dx is going to be equals to, we take this one down, it's going to be 3x squared by minus 1. This one here and the 1, now 1, so I'm going to go to plus 1, marachi minus 1 is x to the power 0, and that's equal to 1. This one is the same as 3, 3 plus, you go to 3 times 2, 8 x to the power 2 minus 1. So here come and mean equal to 1 times 1, x to the power 1 minus 1. The answer is going to be 3 to the power x squared plus, hey, minus 1 is by equal to x to the power 0, and the power 1 plus 2 times 3, hey, 2 your telanta equal to 6 x, because 2 minus 1 the 1. Then the answer in the rabana equal hey. So you know, it's in the polynomial. So that's the polynomial degree, polynomial as it will be when we differentiate them. Sometimes we don't know about differential y equals to 1 over x. When we differentiate 1 over x, remember so this is the same as x to the power negative what? 1, which means dy, dy over dx is equals to negative 1 is going to go down. It's going to be negative 1 x to the power negative 1 minus 1. In the answer, it does equal negative x to the power negative 2. In the as negative 1 over x squared. Where you want negative 1 over x squared. So let's say, you know, then is about 3 differential equation. The polynomial is fine. You can get them. Now we have ln of x. We have e to the power x. We also have cos of x. We have sine x. We have also 10x. Then I will start with 1 by 1. If I'm differentiating ln, if I'm finding dy over dx of ln x. Normally, if I'm writing it like this, I have to say d over dx of ln x. I must not really write this. Then this is going to be equals to 1 over x. Dear ln. So mostly 1 over x. What is the meaning of that? So the meaning of that, it means that this is a standard format. That every time when you see ln x, remember ln x works as a logarithm. So it's going to be 1 over x. Sometimes we can have a question that our y equals to what? Ln x squared. So mostly ln x squared, if I have on x squared, every time when you see this one, remember you can write this as equals to 2 ln what? Ln x. So even if we're saying what is so, if we have to differentiate d over dx of ln x squared, this is going to be equals to 1 over x squared. X squared. Then because apaka x, we differentiate what is inside here. What is inside x is x squared. When we differentiate, we're gonna get 2x. So the answer becomes 2x over x squared. In the answer, this x we cancel with this one, we're gonna remain with 2 over x. So if you use this one, then when we differentiate d over dx of 2 ln x, this is the same as equals to 2.1 over x of this, because constant, a number, we can take them out of our differentiation. So when we take it out, it's going to be 2.1 over x. We differentiate ln x. Then the answer still remain, if we rewrite it this one, this is 2 here, it's going to be 2 over x. So it's the same. So this one more You must do more questions based on the differentiation. So we're gonna move to e to the power x. So with e to the power x, so if we have this one, if we are differentiating e to the power x, dy over dx of e to the power x equals to e to the power x. It does not change. But the problem part, if you have e to the power, let's say x squared, the first thing that we do here, it's not like we are not differentiating. When we differentiate this, because it's just x, it becomes 1. Okay? So that's why we just write it as e to the power x. So if I have to differentiate d over dx of, let's say, e to the power x cubic, the first thing that I'm gonna do, I'm gonna write as it is e to the power x cubic. Then I differentiate this part. Then when I differentiate x cubic, it's going to be 3x squared, which I can just rewrite it as 3x squared e to the power x cubic. So you can practice more of this one for ln and e. Then we have integration of, we also have integration, not integration, I mean differentiation, of course, of a trig. So d over dx of cos of x. You can use cos theta, it can be cos theta. This one, if it's cos, it becomes negative sine x. These are standard one, which you must not forget. D over dx of sine of x, the answer is equals to cos x. Then d over dx of 10x, the answer is equals to sec squared x. So this one you can remember them. So now what happens is that when you remember this one, for example, how did we get sec squared x? We can, sometimes you might want to be, the question might want you to prove this one. So if we have to prove this one, we know that, okay, if we are differentiating our d over dx of 10x, this is the same as equals to, I'm differentiating what, or we don't really have to write equals to there. This implies that, we can just say this implies that our d over dx of this one, we can write it as sine x over cos x. So this one is going to lead us to, this one is going to lead us to the rules of differentiation that you have to take into account. So those rules, I'm going to mention them here. The first rule I'm going to talk about is a product rule. Product rule. Product rule, it states that if you have a function, let's say we have a function h of x. So this h of x is composed of two functions, which we can call them f of x and g of x. So if I have to find h prime of x, this is the same as I can first differentiate f prime of x, then multiply it with g of x as it is, then plus, then I'm gonna differentiate g prime of x, then I multiply it with f of x. So now people, when they see this formula, they get confused too much based on g of x and h of x. So this one, it means that I can have a function h of x, which is equals to, for example, x e to the power x. These are two functions. This can be another function, and this can be another function. So if I have to find my differentiation h prime of x, I can first decide to differentiate x. Then I'm going to be left with e to the power x plus, I differentiate e to the power x, it's going to be a, again, e to the power x is the same as e to the power x. So this is my h prime. So which means I can even rewrite this as e to the power x in brackets 1 plus x. So sometimes it can be h of x equals to ln x cos x. So if I have that, then it means that if I want to find my h prime of x, my h prime of x, I can first differentiate ln x, then it will be 1 over x cos of what? Cos of x plus, I differentiate cos x is going to be negative sine x, then ln of x. So if I rewrite this one is going to be cos x over x minus sine of x ln of x. So I just differentiate that. So now we have talked about the product rule. Then we're gonna go to a quotient rule. So the other one is called quotient rule. So the quotient rule, it states that if I have h of x, h of x, which is equals to f of x which is equals to f of x divided by h of x, then what will happen here is that I'm gonna erase it. Then what will happen is that if we have to differentiate, we will have h prime of x is going to be equals to, with square g of x, then we first differentiate f of x, then we multiply it with g of x, then we subtract, then we differentiate g prime x, then we multiply with f of x. So now this one is gonna lead us to a function whereby if we have h of x equals to sine of x divided by cos x. Remember, sine x divided by cos x equals to 10x. So if I have to find h prime of x, then h prime of x is going to be equals to, I'm going to square cos x then I will differentiate sine x. When I differentiate sine x, it's gonna be cos x. Gonna be cos of x. Then I multiply with cos x again because I'm not, this is g cos x. Then minus, I will differentiate cos x, then it's gonna be minus minus, which is gonna end up giving us minus in brackets minus. When I differentiate this one, it's gonna be sine x Then I multiply it with this sine x there. It's going to be sine x again. So now if I simplify what I have here, we will see that we have cos squared x plus this negative times negative is positive plus sine squared x over this one is the same as we can write it as cos squared of x. So now, according to the rules, we know that sine cos squared x plus sine squared x equals to 1. So this is going to be 1 over cos squared x, which is going to give us equals to 1 over cos squared x. We know that is a reciprocal 1 over cos of x equals to sec x. So if it's equals to sec x, okay, let me just write it properly. Equals to sec x. So now, which means this is going to be sec squared x. Any question?
No.
Okay, no question.
Yeah, so far it's clear.
So, which means we spoke about the 10 cos and then sec. So now what will happen if, for example, I might be given that my y equals to, I'm just giving an example, sec x. Then I have to find the y over the x. The y over the x. But the problem part, I don't know, maybe the how to write this. So if I know the sine and the cos and the tan, I can know that my sec x is 1 over what? 1 over cos. Then I can now say, okay, my dy over the x equals to, because it's in the form of a fraction, I can say, okay, I'm going to use a quotient. Then I will square my cos x squared. Then I will differentiate 1 is going to be 0 dot what? Dot cos x minus, I will differentiate cos x. I'm going to be, it's going to be minus sine x multiply by 1. So now this one here is going to give me positive. What is going to negative times negative is going to be sine x over cos squared x. So this is the same as we can write it as sine x over cos x. I'm just separating. This is cos x dot. I can say this is 1 over cos x. So that these two, when they multiply, they give us cos squared x. So here now I can see that sine over cos, we know that is 10 x. And 1 over cos, we know that is sec x. So which means the differentiation of sec x equals to what? Equals to 10x cos x. So now you might be working with, for example, we have functions that normally confuse students. The functions that confuse students, they are functions like cot x. We have a cot x. So if I'm writing cot x, I know that this is the same as 1 over 10 x. So now we know that, okay, if we are differentiating 10x is sec squared x. So my differentiating dy over dx, dy over dx of this is going to be equals to, I can use what? I can still use the 1 for 10. It's going to give me 10 squared x. Then this one is going to be 0 minus, when I differentiate 10 squared, when I differentiate 10x, I'm going to get sec squared x. So now, if we check here, we're going to have negative sec squared x over 10x. So what is 1 over 10x? 1 over 10x, we can just write it that 1 over 10 squared x. So 1 over 10 squared x is the same as 1 is the same as sec squared x. So we have minus sec squared x dot sec squared x again, which this is equals to negative sec to the power 4 the power 4x. So that's how you can also differentiate the those formulas. So this is the simplest, this is the basics of differentiating. So in this the differentiation, it does not matter, maybe you can try many questions, they all comes around for first year. So there is not much that you need to know about differentiation. You can try to do some questions. It can be, there is nothing complicated about differentiation if you know the rules.
Okay.
The only one maybe I didn't speak about is chain rule. You also have a chain rule. Chain rule. What is chain rule? Chain rule is that if we have a function, it can be a function of h of x equals to, inside this function, there is a function. It's like a composite. We have maybe g whereby, or f, g in brackets f of x. So in other words, which means when I get my h prime of x, my h prime of x is going to be g prime of x, f of x, then f of x, f prime of x. F prime of x. So what is the meaning of that? It means that if my h of x equals to, h of x equals to, let's say, x squared plus 1 to the power 2. Then in order for me to find my h prime of x, then I'm gonna take this 2 down in brackets x squared plus 1. Then I'm gonna subtract by 1, it's gonna be like that. Then I differentiate what is inside here, which is x squared plus 1, then it's gonna give us 2x, because we're going to differentiate 2x and this constant is gonna be 0. Then if we are rewriting it, we can just rewrite it as 4x squared plus 1. If you want to change, take it further, you can take it further to be 4x cubic plus 4x. So that's how we differentiate for a chain rule. So chain rules are more like of composite functions.
So when we're differentiating what's inside the brackets, we make it an exponent.
Which one? This one.
In the following step.
Which one? This one.
Yeah, because I see that the 2 of x that's outside,
No,
it kind of looks like.
No, this 2x here, this one here. Remember, if we differentiate x squared here, the results x squared plus 1. if we differentiate this 2 is going to be 2x plus 0.
Yes.
So which is still is equals to what? 2x. So we differentiate outside. The formula says g prime in brackets of x, close brackets f prime
Oh,
x. So that's why it's 2x there. It's this one. We differentiate what is inside. So it's like there is g of f of x is x squared plus 1. F of x and g
oh,
of x is x squared only. The functions that are here in these functions here, in this question, is like we have x squared and we also have x squared plus 1. But this x squared plus 1 is inside x squared. So that's why it end up being squared like this. It's inside.
okay, makes sense.
All right. So that's how we do it. So with differentiation, you will try to do maybe more exercises and examples. Then we're gonna move to integration. So integration, for integration, which is represented by this, we going to be checking. The first one is that if I am integrating x to the power n dx, then this is the same as x to the power n plus 1. This is the first rule that you must take into account. N plus 1 plus c. This c, it means constant. So this one, it means that I can be given equation y equals to x squared, for example, the simple equation. Then my integration of x squared dx is going to be equals to x to the power 3 over 3 plus c. Sometimes when we work with integration, you can have equation y equals to x to the power 3 plus 2 to the power x squared, maybe plus 1. So when we integrate this, which is x to the power 3 plus 2x squared plus 1 dx, we can break it into parts. When I say break, it will be, is the same as you can start by x cubic dx. Then when we say plus this 2, it can go out of the integral. Then we can write it as like 2 integral of x squared dx. And then integral plus again, this one can be out. You can just say dx like that. So now the results here, if we integrate x cubic, is going to be x to the power 4 over 4 plus 3, 2. Let me first say 2 dot x to the power 3 over 3 plus x. When it's just integral like this, there's nothing. The result is just x. It's just this value there.
Okay.
Plus, again, constant. Remember, you must take into account that when we say integral of dx in this way, this is the same as integral of x to the power naught or x to the power 0 dx. So x to the power 0 is the same as anything to the power 0 equals to 1. So when we make this one, it's going to be like x to the power 0 plus 1, according to the formula, over 0 plus 1 plus c. Then the answer is going to be equals to x to the power 1 over 1 plus 1 plus c. So which is going to be x plus c. So when we integrate, now we just spoke about the basic one. when we integrate about the like let's say for we have the one for e to the power x, which I'm gonna introduce it to you. So integration, we won't really finish it today. There is a lot of things that we're still going to break out. So we're just gonna take it from one step to another. There is a lot of things. So we're gonna start by the basics. If we have cos of x, sine x, tan x. So this integral, you must remember them. So integral of cos x, we know that equals to what? Equals to sine, is positive sine x now. Not the same as when you're differentiating. And remember, here you must write dx. Ne? And integral of sine x dx equals to negative sine x, negative cos, sorry, not sine, negative cos of x. So integral of 10 x equals to ln absolute value of what? Is it 10x?
Yes.
Then sec x, sec,
Is
not
it not
10.
sec?
Yes, it's sec x. And everything here, don't forget to put plus c, plus constant, plus constant. So now when we have this one, we also have integral of e to the power x is equals to e to the power x plus c. And integral of ln x equals to, what is the integral of ln x?
Is it not 1 over x?
No, that one is the integration.
Okay.
So integral of sine x, yeah, I'm forgetting to write the x. I must write it. It's very important to say the x everywhere. The x dx, yes. So integral of ln x is, it becomes different when
Okay.
we integrate it, is because this is a logarithm. So the formula for this one when you integrate, let me think, is 2. I want to say a. What was that formula? There is a formula. There is a formula that we use to. There is a formula that we use there for ln x. So ln x is a little bit different. So the integral of ln x is x ln of x. It's x ln x, yes. It's not the same as the one for x ln x minus what? Minus x plus c. So this one is more different, but normally in majority of the questions, they won't really ask you about that question. They don't really, many questions, they don't really include the integration of ln x.
Okay.
Mara, you must know it. They will be there in there are there. So now The question can ask you to integrate anything. For example, you can be given e to the power x squared dx. So when I'm given e to the power x squared dx, I have to integrate it. So in integration, we have something called integration by substitution. Substitution. So integration by substitution is means that I'm going to say let I'm introducing another variable equals to what? X squared, because I don't know what is integral of x, e to the power x squared. I will just say x squared, the one on top there. Then if I say my du over the x, this is going to be equals to 2. This is 2 here, 2x. If I multiply everything by dx here, I'm going to have my du equals to 2x dx. So normally this question, when they ask you, there will be maybe x here, like this way. So now I can divide by 2. If I divide by 2, I divide also by 2 here. Then which means I'm going to have my 1 over 2 du equals to x dx. So now if I have x dx like this, we go to this equation, you will see that we can rewrite this equation as integral of e to the power x squared x dx. This x come this side, dx. So our x dx here is the same as equals to 1 over 2 what? Du. And our x squared is equals to u. So we can rewrite this integral as integral of e to the power u, which is equals to 1 over 2, where there is x dx du. Then when we solve it, we can take out 1 over 2 outside of the integral. I will have 1 over 2 integral of e to the power u du, which is going to give us 1 over 2 e to the power u plus c. Then now I can substitute back u. We know that it was x squared. Then the answer, it can be 1 over 2 e to the power x squared plus constant. Plus constant. So that's how normally we do it. So if you get another questions, let's say for example, we can be given maybe let me get some few questions. Let me just say exercise on integrals. Exercise. So we're gonna just get some random questions here in this. I'm not getting anything. I'm not good with searching on internet. I just don't like it. So, okay, for example, there is this one for square root. This one you're gonna do it. I think this is, yeah, you're gonna try these ones. They are simpler. These ones I won't do them. I want something challenging. So this one you will do them. I'm gonna give you this guide. This thing is very good. I'm gonna give it to you this one. I'm gonna download it. We will do this one. I
Okay.
want something that is very challenging for those two, but it's only those one. But I think this one, they are more easier. They are very easy. But these ones here, there are some other things that you don't have to check them now.
Okay.
This one is not, it does not really have what we want. Because, for example, if I have to differentiate, we are given, okay, let's say, let me take this one. This integral is integral of 2x plus 6 to the power 5.
Mm-hmm.
Integral of, it was 2x plus
2x
what?
plus 6
To
to the
the
power
power
5
5 dx, okay,
dx.
dx, yeah. So now, when we have this integral, what we need to do here, we can let, is an integral by substitution. We can let our u equals to what? 2x plus 6. Then, which means my du is going to be, my du is going to be equals to what? 2 dx. Né? Then when it's 2 dx, I can divide by 2. This implies that 1 over 2 du is going to be equals to dx. So when I go to this integral, where there is 2x plus 6, I'm going to substitute with u. Which means I'm going to have u to the power 6. Is this not 6, 5? I'm going to have u to the power 5. Where there is dx, we have 1 over 2 du is this one equals to dx. Then now this is going to be 1 over 2 integral of u to the power 5 du, which is equals to 1 over 2 integral of u. We know that is going to be u to the power 6 over what? Over 6 plus c. So if we simplify it further, this is going to be u to the power 6 over 2 times 6 is 12 plus constant. If you substitute back where there is u, you know that u is 2x plus 6 is going to be 2x plus 6 to the power what? 6 over 12 plus what? Plus c. So this is how we use an integral by substitution. So if we check here in that document, you will see that they are showing you the steps 1 over 2, 1 over 6 until they get is the same answers. So you can first maybe practice with the substitution ones. There is a solution there. This one we already did something like this. It's exactly the same. Even if we take this one, let's say is e integral of x to the power 5, e to the power 1 minus x cubic. If I have that integral whereby I have to integrate x to the power 5, e to the power 1 minus x to the power what? It was 6, ne? The
I
x,
didn't
is it
see
6?
problem.
Yeah, I think it's 6 there. Is it
Okay.
not 6? Yeah, let's check, verify. Yes, it's 6, yes. So now I can let my u, we can let u, this is by substitution, u equals to 1 minus x to the power 6. Then our du is going to be equals to minus 6x to the power 5 dx. Then which implies that our minus 1 over 6, we divide by 6, du is going to be equals to x to the power 5 dx. So x to the power 5 dx is there. Then when we take this integral, it's going to be e to the power u minus 1 over 6 du. Then this is going to be equals to minus 1 over 6 integral of e to the power u du, which is going to be equals to minus 1 over 6 u e to the power u plus c. So if I have to rewrite this, I can rewrite this as minus 1 over 6 e to the power, where there is u is 1, minus x to the power 6 plus c, which we can also rewrite this as minus e to the power 1 minus x to the power 6 divide by 6 plus c. So that's how simple we work it out. So at least this document that I'm going to send you, it have the solutions. So you will work with this one. For integral, start with a simple one. Then after starting with a simple one, then it's gonna be 5 years.
Okay.
Yes, so I think that will be better. You can also start with this one. See, I think they are very nice. And there are many questions there. I'm not sure it have 34 pages. You can start at the first page, take 10 pages for one day, for today, trying to practice, getting to understand. Then after that, yeah, you'll be fine. So which means for with integrals, we're gonna do more questions. But when we do more questions, we're gonna do more step by step so that you can understand properly. Because if we do everything same time,